Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look at library date functions. In this series of videos, I'll be covering the creation and use of libraries. So you might ask, why use libraries? Why not just write code whenever you need it? Well, if you're writing a lot of applications, having common libraries that contain functionality that you use often will save you time, both coding and testing. It will also make your code more readable and therefore maintainable, which is always a good thing. Today we're going to take a detailed look at the date functions library we have created in a previous video. And we've added a few extra functions to that library just to make life a little easier when it comes to handling dates. We've included the date functions library at the beginning of our code with this include statement. Include libraries datefunctions.inc. The purpose of creating library functions is to make your life easier. However, when these functions are used by people other than yourself, it always helps to have a little bit of documentation so that the user of a library can actually know where to find the functions they actually need. Certainly a minimalistic approach to this is to have an index of your functions at the beginning of the library, listing the names of all the functions, the parameters, and their purpose. This way, a user of your library can quite easily scan down the index to find out if there's a function in the library that will do what they want it to. So at the top of our functions library, we do indeed have an index to the functions. To illustrate what we can do with these functions, we're going to step through a few examples. Say for example, you wish to do something with the current date, and we create a local variable to contain our current date. Now you can use date $, which is an inbuilt little function to PowerBasic to return the current date. This will return the current date in the US format, as in month, day, year. If we send that out to our log just to see what's going to be returned, we will see we'll get the date format in month-day-4 year. Now if this is all you need, then there's no need for an additional function. However, if you're in the UK, you may want the date in a different format. So if we run this, we will see we get the date format in the standard UK format, day/month/4 year. If much of the code you write is actually handling dates, especially the current date, this is a nice easy way to get the date in the format you need. You may also want to pick out the month name for reporting purposes or for anything else in your application. So we have another function whose purpose it is to return the month name, given the month number. And in this case we're picking the month number out of the variable we have populated with the current date. So if we try running that, we will see we're getting the month name equals June. Now the beauty of using libraries to return standard information like this is if you have many applications all using that library and you discover that there is a better way to return the information, you merely have to change the library and then recompile all the applications. You don't have to go into each application individually, change the code there, and test them. This can save a great deal of time. So if we have a look in the library for this particular function, we'll see in this case it takes a number in a string format, being the number of the month, and depending on that value, it will return the long name of the month. While this works remarkably well, it's unlikely that the names of individual months are going to change. So we can amend this code to use another inbuilt function to PowerBasic itself. And this would involve replacing all these lines of code with a single line. There is a month name function inbuilt to PowerBasic, which given the month number in numeric format will return the long name of the month. So if we try running that code, we will see it returns the month name quite happily. So that's a quick demonstration of how you can change a common library to use new or possibly more efficient code without having to change it inside your main application itself. Merely changing the library and recompiling would do the job nicely. One of the things you may find yourself having to do is to validate information that has come from some external source, some source not under your control. This may be in the format of a file containing records which have dates in them. One thing you may need to do is to validate the dates to ensure that the date is valid before you do anything else with it. So the first thing we'll do, we will populate a date variable with a 30th of the June 2021. Now this is a valid date as we know, and we have in our date functions library some date validation functions. We have two date valid functions, one for the UK format and one for the US date format. These functions will return a true or false. True if the date is actually valid, and false if it is not. So if we run that now, we will see that it says the 30th of June is valid. If we deliberately give it a date which is not a valid date format, for example the 31st of June, which obviously does not exist, if we run that, it will tell us the date is not valid. Similarly, if we actually pick numbers which are out with the range of months, for example month 13, it will also tell us that that is not valid either. If we have a look at that actual function to see how we perform that, we'll see in this case it's taking the date format in, and this can have any delimiter you wish between the day, the month and the year, as it's picking up the year from the last 4 characters, the month from the middle 2 characters, and the day from the first 2 characters. And we're calling a common function, passing it 3 parameters, year, month and day, called isDateValid. And isDateValid is using the PowerTime class. This is an inbuilt class to PowerBasic that is very powerful. You first declare a date as iPowerTime. Then you can specify it's using the class PowerTime. You can populate it with a new date with the 3 variables, the year, the month and the day, which we've passed into this function. And quite simply, if the object result of that is this constant here, OK, then there is no error occurred, therefore the date must be valid. If this returns anything other than SOK, then the date is not valid. So with a very few lines of code, we can validate any date we're given. The PowerTime class is also very powerful for adding or subtracting days to an existing date. So you can quite easily work out what is today's date, what is yesterday's date, what is next week's date, just using this one class. So you will see in this date library there are a number of other functions. I'll let you go through these in your own time, but these are basically functions I've found that save time when I'm writing applications using dates. But that's it for today. Thank you for watching.